Welcome back, Marauders. In this video, we're going to review how to find the bond angle of a molecule. And so all molecules are based on these five basic shapes. So there's linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. And so you want to look at the total number of electron domains. And if there's 2 electron domains total, then you have linear. If there's 3 electron domains total, you have trigonal planar, and so on, with 4, 5, and 6. To figure out the actual shape, you're going to look at not just how many electron domains there are total, but how many are bonding and how many are non-bonding. If, like in this trigonal planar one, if you have 3 and they're all bonding domains, then your electron domain geometry and your molecular geometry are the same. It would also be trigonal planar, and all the bond angles would be 120 degrees. If, however, one of these were a non-bonding pair of electrons, so if one of these were a non-bonding pair of electrons, then that would alter the bond angle a little bit. The non-bonding pair of electrons actually repels everything else a little bit more, so it would actually squeeze these two closer together, so it would make this slightly less than 120. You don't need to know exactly what it is, you just need to know that if a molecule is a bent shape based on the trigonal planar arrangement, that is 3 electron domains total, 2 that are bonding, 1 that's non-bonding, then the bond angle is going to be a little bit less than it would have been, so a little bit less than 120. In tetrahedral, it starts out at 109.5. You need to memorize all the original bond angles. If one of these were a non-bonding electron domain, it would squish everything else together. It would repel a little bit more strongly than a bonding domain, and so it would make, in a trigonal pyramidal molecule, the bond angle is a little bit less than 109.5. Again, you don't need to know the exact value, you just need to know that it ends up a bit less than 109.5. If it were a bent molecule, so that'd be one that has 4 electron domains total, 2 which are bonding, 2 which are non-bonding, then these 2 non-bonding electron domains are going to repel even more strongly, making it a bit less than 109.5. It would also be less than if there were just 1 non-bonding electron domain. That would make it a little bit smaller. If there's 2 non-bonding electron domains, even smaller than that. So make sure you know all of the basic shapes, all the electron domain geometries that are possible, know their bond angles, and then know that they get a little bit smaller when you have non-bonding electron pairs. Over here, trigonal bipyramidal. So you have 2 different bond angles here. So you've got the one at the top and the one at the bottom, and then the 3 in the middle here. These are 90 degrees from each other. These are 120 degrees from each other. So you have 2 different bond angles that you're dealing with. When you have one of these as a non-bonding pair, so take one of those away, it would be one of these in the triangle plane in the center here, that's taken away to make the seesaw shape. So when one of those is removed, it makes these other remaining bond angles a little bit smaller. So these would be a little less than 120, and these would be a bit less than 90. If you take 2 of these away, you're getting the T-shaped molecule, and so in a T-shaped molecule, the bond angles would be a bit less than 90. If you do take all 3 of these away, then you end up with a linear molecule. And the linear molecule, these are going to be exactly 180 degrees apart. So since all 3 of these are non-bonding domains, they can't really squeeze those closer together because it's like symmetrical. So it ends up being still 180 degrees apart. You can kind of visualize that. If all 3 of these went away, there's really no way for these 2 remaining molecule or atoms to get any further apart from each other. So it would just stay at 180 degrees. Octahedral, same sort of thing. So all the bond angles are starting out at 90. If one of them is a non-bonding electron domain, then it squishes everything a little bit closer together, so everything's a bit less than 90 degrees. If you take away 2 of them, again, the bond angles were all at 90, so they get to be a little bit less than that. And just like with the trigonal bipyramidal, if you take off, let's say, like all 4 of these, then these would be exactly 180 degrees apart. So that's how you figure out the bond angle. You need to know all of these bond angles, have those memorized, and then from there, just know that when you remove something and have a non-bonding electron domain, it repels a little bit more strongly, therefore making the bond angle a little bit smaller than what you would have originally expected.